we get moving on with the lab today, I just kind of wanted to mention some updates that are happening in regards to 2007, the campus itself. Chances are you guys are all pretty enthusiastic about the notice sent out by the Protect Purdue people, stating that masks are no longer required in special areas coming March 14th. I am still expecting masks to be worn in this area just because it's so close proximity. I am asking you all to put on a good example and do the same. And the syllabus that, if you guys were on Piazza last week, the week before, there were some people freaking out about not getting credit for doing the syllabus agreement. And then they signed the syllabus agreement. And in the syllabus agreement, it says that you will be wearing masks for the remainder of the semester, regardless of what happens. So whether people want to wear masks or not, they already agreed to do so. So that's kind of the argument there as well. Again, we're in close proximity here. I understand that case numbers are down, and that's fantastic. But I would rather err on the side of caution. So that's kind of my stance on this. And again, I would ask all of you to host that example as well. If you do want to talk that up with me later on, you're welcome to do so. I will tell you right now, it's going to take a lot of convincing for me to change my mind. So just a notion on that. Yeah.
I think that students can still haven't signed the certification.
They're still in this class and they're expected to abide by the syllabus. So regardless if they signed the agreement or not.
Like a zero for that assignment now, right?
Pardon?
That's that's a zero for the assignment now, right?
At this point, it's at a zero for the assignment. They had their initial time. We gave them some leeway. At this point, if they haven't done it yet, they're not doing it. So, and yeah.
What if the student doesn't comply with this thing?
Then you can have them come to me. I'm more than happy to talk to them about it. So that's not something you guys have to deal with. If they are, specific. So if you guys also read the terms that were sent out by Protect Purdue, they said that if an instructor or professor or someone in the area asked you to put on a mask, they ask that you do so. Right? I do not think it's an unreasonable request. If we ask someone to put a lab or a mask on, don't put a lab on your face. But if someone asks you to put a mask on your face in a situation like this, I do not think that's an unreasonable ask. So please feel free to ask. And if they decide to not, then we can again have that conversation, me and them if needed. So, fair enough? All right. This is a fun lab coming up. Lab 8 op-amps. I don't know, this tends to be a pretty good favorite of students. It's not overly complicated, but you get to do some really cool stuff. And op-amps are inherently extremely useful in lab and in a variety of other situations. It's not super covered in this lab, but I think it's worth, who knows what happens with positive feedback in op-amps? Got a few? What happens? What does an op-amp do in positive feedback? Okay, now on, you raised your hand, that's fine.
Driven to saturation.
Yeah, so it just drives it directly to either the saturation on one side or the other, right? And the interesting that happens is you can actually create thresholds, right? And in fact, you can create 2 thresholds, technically 3 if you really wanted to. But ones that ends up happening is this is what happens with a lot of homes, say thermostats. You don't turn it on the second it drops to, 68. You don't turn your AC on when it drops to 68. You wait until it rises up to about 70, and then it'll kick off at about 65 degrees. Those are 2 different states. So you can create that using a positive feedback loop with an op-amp, which is kind of cool. Okay. Again, it's not super covered. We're not going to go super in depth. The math gets kind of funky pretty quickly. But it's a cool thing to talk about. Okay, and I would really recommend if people are interested in using op-amps for, say, home automation and stuff like that, it really might be worth looking into how positive feedback works. So I just kind of wanted to mention that. They should already have a general idea of what negative feedback does, even if they don't necessarily know what that means. They already made a buffer, right? That's essentially what negative feedback does. We can change the gain by adjusting that voltage divider that goes across V out and your input on V in, and you can either invert that or not, depending on which pole you put it on. But they should already kind of know what that means. So now we're just driving home what they already know, right? That's ideally what we will be doing in this lab. So enjoy it, have some fun with it. There are some kind of interesting things that people tend to get wrong. I mentioned that in the PowerPoint here. It's also one of the shortest PowerPoints yet. I'm trying to decrease length as the semester goes on. Hopefully we can focus less on specifics and focus more on the big picture of what's going on. So we'll see if that actually works out. Any questions for me? All right, get your grading done. I'm going to say that every week. We're getting better. Okay, I'll be the first to say that. It is getting better. Still got a ways to go yet. We can still be improving. As again, we improve Brightspace, as we make sure that's going smoother, that will hopefully get quicker. But please keep on top of it. If you notice the lab bench is acting weird, whether it's connective issues or anything else like that, please go ahead, put one of these magnets on the actual bench number. It just says do not use. A TA recommended this, and I thought it was a great idea, so I think it's worth implementing. The next step will also be, we'll have another set of magnets here that has the actual bench number on it. So that way, we'll make a table over here about, say, is it an equipment issue? Is it a computer issue? Is it a driver issue? Is it a bench view issue and stuff like that? So that way, when I come in and say, you know, we have all these stations that are not working, instead of just saying they're not working, let's go ahead and try to narrow it down a little bit. So, and we could try to maybe formalize that. And hopefully we'll have less headache from students. So that way, when they come to a bench and they say, hey, it says do not use, maybe they won't actually use it, even though they probably will. We'll see. That's about it on my side. Let's go ahead and keep moving.
Okay, cool. So as Ben was saying, this week we are going to be working with op amps. They've had a very general introduction to op amps, like as a buffer, but in 20,001, they do not really cover op amps. So for all the GTAs, it might be a really good idea to just post a Brightspace announcement saying that, you know, this week especially, it's extra important to watch the pre-lab videos because those will help give a lot of the necessary background and intuition. Because if they watch those, they'll know what's going on and be able to follow. And if they do not, they will probably be lost. So with that, the purpose of this lab is get the general fundamentals of op amps and watch lab videos. So the op amps have voltage dependent supplies based on the inputs and gain. Essentially, you know, we should all be familiar. An op amp takes, you know, you input a signal, and generally, you know, if you have your gain more than 1, it will output a larger signal. So your gain is just the ratio of V out to V in. In the op amps, they have their internal gain, which is set as the ratio between the, so V out divided by the ratio between these inputs. It's often incredibly huge, like on the order of, like if you saw an internal gain of like 10,000, that would be actually really low.
Most of the time it's done in decibels. So often say for the, what is it, the one we're using?
264.
324. It has an internal gain of like 110 decibels. So that's big.
Yeah. So V out, you know, and op amps are really amazing tools, but they're not magical. You know, they can only output up to what we supply them. So if your output would go above your positive source value or below your negative source value, it'll just clip and output that value. Yeah, and then if you have them in an open loop configuration, that'll be like infinite gain. So they'll just saturate very quickly, as people should be seeing in the pre-labs. So by connecting the output to one of the inputs, we're able to create feedback, which allows for more stability and more predictability. So internally, the op amp, the positive and negative inputs will always be very close to 0 volt difference. And typically it's so small, we can just say V plus equals V minus without hardly any error. And as noted here, connecting V out directly to V minus will give a gain of 1, making a voltage buffer, which is what they did in lab 5. And then if they put resistors in the feedback network, they can control their gain with that. So if you put in positive feedback, in that case, it'll then, just keep saturating until it reaches the supply voltage. So that turns the op amp sort of more into like a binary device that either has like its high or low settings, and it'll transition between them pretty quickly. So some tips for lab 5. So it's task 1 is just a very classic non-inverting amplifier. Task 2, they should have everything from the pre-lab. One very common mistake that I know I saw last semester, and I'm assuming lots of you saw last semester as well, is people will see the crossed wires and think that they connect. So please be sure to state that, crossing wires are just that, crossing wires. And it's only like when there's a dot at the intersection that shows connection there. And again, task 3, very similar, common issue. And just make sure they are understanding like which chip is which. And then I'm going to go through the tasks real quick. Pre-lab, okay. So non-inverting amplifier, fairly straightforward. We can calculate the non-inverting amplifier formula. Would anyone like me to show how to calculate that on the board, or are we all good with that? Good? Okay, cool. Then we'll construct the figure, apply a sine wave. So again, sine wave in, they should be getting a sine wave out. Task 8.7.2, there can be a handful of unusual issues with this. Sometimes the circuit will be set up like perfectly. There's one with the single-sided op amp, but for whatever reason, the V out will just saturate to a DC voltage of about 3 to 3.5 volts, which is very unusual. You can have them try increasing the values of C1 and C2. That's one good way to test it. And another thing is, for whatever reason, if you apply a small DC offset to V in, such as 100 millivolts or 200 millivolts or so, a lot of times that can fix it. To be honest, I don't know why, because by definition, that capacitor in series with V in will block any DC component, but for whatever reason, that seems to work. And then task 8.7.3, they're going to be looking at a comparator versus an op amp as a comparator. Really, the op amp is not truly a comparator. It's just that it has infinite gain. Since there's no feedback resistor, so it'll just saturate quickly and act very similar to a comparator. So everything's fairly straightforward. And then in step 6, it says to capture a screenshot of an XY plot of V in and V out. What would be the most interesting, you're for sure going to want to recommend that they put the V out on the op amp, because then they'll be able to see the You'll be able to see the hysteresis that's formed from the op amp there. And as well, if you have them put their input directly connected to that triangle wave, it'll just give a more interesting output than any other combination. Theoretically, any combination of an input and output will work, but this is the one that is most interesting and that they can probably learn the most from. So I'd recommend, while we're talking, making that announcement. And then from step 9 on is going to be extra credit in this lab. So I believe the rubric, the rubric reflects that because it's the same as last semester. So yeah, steps 9 and beyond are going to be extra credit. So are there any questions about lab this week? It should hopefully be fairly straightforward. Again, the common issues are connecting wires that should just be crossing. And then for whatever reason, the single-sided op amp can saturate. And if you just put a DC offset onto the input, that should help clear it up. So any other questions? Okay, seeing none, I will pass it back over to Ben if he has any last announcements.
Don't believe so. Any general questions, either administrative wise or lab wise right now? Yeah.
So I just wanted to make a comment.
Yes.
So I had a lot of, and I think,
Just from having to change partners?
yeah, just from having to change partners, and plus they didn't really have one.
So, we mentioned that at the beginning of the semester.
We didn't have the audible part, but like they basically like didn't have basically like both two like they would switch off kits. Some partners one of them would, so there was a big logistical issue there. But feedback about, I can see how it makes sense for some people who have like really bad partners. But for people who have like really good partners, one of them for they kind of like were mad they had to move to another section or something like that. So I don't know. I was just trying to give you guys like what happens during my section.
That's fair. I appreciate that. The truth of the fact though, they have to learn to work with other people, whether they're good partners or not. It's something they got to deal with. And I'm sorry for breaking up friendships. I hope I'm not actually breaking up friendships. I'm glad that they found a partner that they liked working with. That's great. That'll become very helpful to them in future classes because chances are, especially if they're in ECE, they're going to be following each other in classes probably pretty closely. But at the same time, you need to learn how to work with other people too. Right? So that's the reason for that. I do agree. Next semester, we will make sure that they at least know, during practical, we'll probably say, hey, just an FYI, you're changing partners next week. So make sure you bring your stuff. So stuff like that. Yeah. Yeah, sounds good to me. I think that's a great idea.
Should we put it in the syllabus? I think.
Yep.
I think we should tell them during the report that way they could make.
That's also a good idea. I like that too. Cool. That's a good idea. Yeah.
One of my previous EC classes, it was for EC 395.
Yep.
There was actually a way on like face. You could find partners.
Oh.
So you could set that up. I don't know how to set it up, but there is a way. If someone knows like ahead of time, like before the lab starts, like a week before, you can make it close to like find the partners.
Yeah.
That's a good idea. I might look into that. Okay. There was one other thing. That's a good idea. I'll look into that too. Yes, that's what it was. Thank you. Appreciate it. So you guys all should have gotten an email from me, what, 4 hours ago? Saying that, I want to meet with you guys. All the GTAs are already scheduled to time, so thank you for that. Appreciate it. I just wanted to give them kind of the first run of times just because, I mean, they're kind of in charge of you guys right now. So, but I do want to talk with all of you as well. You guys are on the ground every single day with this. I'm kind of not able to be here every minute of every day. So thank you for doing so. I want to hear from you. I want to know how things are going. I want to know how newer labs went. I want to know how the older labs went. I want to know how you're doing individually. Okay? And again, this is paid time for you. So please make sure when you have your meeting with me, make sure you put that on your timesheet. But I just want to hear, make sure things are going okay with you and we can keep moving from there. Any questions on that? Okay. Anything else for the good of the group?
Are you lost?
Are you lost? It's an important update. All right, please make sure you guys do the lab before lab sections. I know that's easier said than done sometimes, but please, you have students that are relying on you knowing what's going on. So please do the lab before. Thank you.